Now we are going to start on our third property for today. And this is our third lesson. And the property we are going to look at is called the same-circle theorem. So this is the property that we are going to look at. We are not going to do this activity, but you can try out in your free time to verify whether what we have come up with matches with this activity. So you'll try it out in your free time. But allow me to go into the theorem. Now, in construction or in engineering, you are going to be meeting figures of this nature when they're designing. When it comes to carpentry, when it comes to even civil works and the rest of that, they use ideas of semicircles. So when you look at this door we have here, you can note that there is an idea, or you can easily tell that there is something about a semicircle. But to come up with this architectural drawing, they use the ideas of these circle properties to come up with those things when it comes to the computer work and other architectural drawings. And now today our theorem that we are looking at is called the angles in a semicircle. That's where we are going to concentrate. If I have this as my circle, and we are going to relate this to what we have had previously. And this is my center. When I divide my center like this, I'm forming a semicircle. A semicircle means it's half a circle. This is one semicircle, and this is another semicircle. So the angle we have here is 180 degrees. Still, similarly, even up here, the angle you have is 180 degrees. If this is A and this is B, we have said that from our previous theorem that any line that is going to be formed inside, this is now our arc that we are considering. So any angle that is going to be formed, as long as the chord is originating from A and B, will always be half. So if I draw a line from here and I draw another line from B, can you tell me through the chart, relating to the property we have been dealing with, which angle do you think we shall be forming at that point? Okay, 90. Very good. Everyone is saying that that angle is going to be 90. And the property, when it comes to semicircles, whenever you find that you are dealing with a semicircle, this angle here will not be given to you. You need to just know it automatically from our theorem that whenever you have any angle at the center, will always be twice the angle you have at the circumference. So that angle we are forming, since this is 180 and this is twice SCB, so when you divide by 2, you'll find that this is always 90 degrees. So angles in a semicircle will always be 90 degrees. So going forward, it is not going to be given to you. But the moment you notice that what you are dealing with is a semicircle, whether they have drawn it like this, sometimes they can come, draw it like this. And here, once they draw it like this, they will come and put something. So for you, the moment you notice that this is the center and this is a semicircle, the angle you'll always have at that point is always going to be 90 degrees. So they will be asking you to find the other unknown angles. So they may ask you to find this angle. They may ask you to find this angle. So, but that is now the property that we are going to look at, and then we shall work out some few numbers. Okay, now this is our theorem, so I'm going to ask you to write it down, and then we continue. So here, allow me to just tell you that the angle subtended at the circumference by the circle is 90 degrees. So that's why here you are saying 90. So the angle we have here is always 90 degrees, as long as you look at it and it is a semicircle. So let's write it. and then we can try out some numbers. Okay. Uh, Chisach has said he has finished. Paul has finished. Okay. 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 It seems people have finished. I think we are good to start. Okay. Okay. May I ask you to first try out this on your own? Everyone is trying out on your own. Okay, that, good. I think that is very okay. People are getting 30 degrees. Okay. Yeah. So like we have said, that is very okay. Someone can raise up the hand and you take us through. Okay. Calvin. Calvin.
Yes.
Okay. You can take us through.
Yeah, morning.
Good morning.
So we are going to use the angle theorem in a semicircle, which states that the angle subtended at the circumference by a semicircle is 90. So meaning the upper angle is 90. Then, since angles in a triangle they add up to 180, we are going to say y plus 90 plus 60 degrees is equal to 180 degrees. So y plus 150 degrees is equal to 180 degrees. So we shall say y is equal to 180 degrees minus 150 degrees. So our y will be 30 degrees.
Okay. Thank you. That is correct. Okay. We can now try out another one. Let's try out that as well. Yeah, people are getting 145, 145. Okay. Someone to take us through. Okay, I'm seeing Elos. Elos, unmute.
Morning, sir.
Morning.
Yes. Now we are going to we are using our theorem, which states that the angle subtended at the circumference by a semicircle is 90. Meaning up there we are putting a 90. Then we are finding, let's put an unknown down here. R. These are the interior angle sum of a triangle is 180. Meaning we have R plus 90 plus 55 equal to 8. R plus 145 equals 180. R plus 145 minus 145 equals 180 minus 145. Our R is equal to 35. Now we have Y plus R, which is 35, equaling to 180. Angles on a straight line. Y plus 35 equals 180. Y plus 35 minus 35 equals 180. Y equals to 145.
Thank you so much. So let me hope everyone is getting that. Yeah, okay, that is correct. That is correct. Okay, thank you. Yes, I think, let me first pick on a hand. Yes, Chiza? Chiza, is it a question? Yes.
No, I have another method, but I've got the same one, sir.
Okay, which approach did you use?
I use that two interior opposite angle equals to that these two angles, yeah, equals to exterior angle.
Yes, that is also very correct. So you have just added 55 and 90.
Yes.
Okay, it is very correct. Okay, thank you. Okay, you can take a screenshot of the exercise that we'll try. No, not really. Before we go to the exercise, can we try out part D together? Yeah, we are trying out part D, this one here. Hope you have seen the number I want us to try out. This number here that I'm enclosing.
Well, when you get the number answer, save.
Yeah. So we are trying out that. Okay, looking through the chat, some people are getting 45, 45, and one person 30, others 22.5, 22.5. Okay, who wants to take us through? You can raise up your hand. Okay. Yes, Trevor.
Okay, good morning.
Good morning.
So what I did, I first named the bottom left A, the bottom right B, then the other part C.
Sorry.
Yeah.
That's
And like the one inscribed in the circle C. So what I did, since since we are using the theorem, we have the 90. Then since it's an isosceles triangle, the other two sides will become, at the base center will become 45, 45. So
okay. So this is 90.
90, 45, since it's
45.
an isosceles triangle, then that side 45 also.
Okay.
So then we shall get the interior angles add up to 180. So we shall get x plus 45 plus 90 equals to 180, which will give, then we shall say x equals to 180 minus 35,
Minus 35.
minus 135,
Okay.
which will give us 45.
45. Okay. Now, this is 90. Not so? Okay, let me
First way?
put here C.
No, first way. Pardon, first way.
Something.
Oh, I made a mistake. I made a mistake.
Okay.
Sorry. I've recognized
What is missing?
there is an angle which I didn't get, so that's what I'm trying to get right now. Maybe let somebody else work it out as I get it.
Okay. Who wants to hold? Oh, sorry. Yes, Emmanuel? Emma? Oh, sorry, Emma?
After getting that angle as 45, sorry, that two sides as 45, there is 5 that is at the circumference, this side. I used the other first theorem that the other angle x will be half that angle, where I got 22.5.
Okay. Okay. That is okay. I'm saying another one. Yes, Magezi.
I used another method. So after getting 45, now at the top right corner, it makes a straight line. So
Yeah.
the other side is one, yes. So the other side after calculation is 135 degrees.
Okay. Here.
Yes. And considering that it's an isosceles triangle, the bottom corners are equal. So you name the other side x, and then we calculate 2x plus 135 degrees is equal to 180 degrees. 2x plus 135 minus 135 is equal to 180 minus 135, which gives you 2x as 45. Then you divide both sides by 2 to give you 22.5.
Okay. Thank you. That is correct. Okay. Yeah. Now those are the approaches that we had to use. But I'm going to first come back here on this approach here. When you look at the approach he used, this approach was okay, but he forgot that the triangle he was considering, he considered this bigger triangle that had 45 here, had x here, but at this point here he had the 90, but he forgot to consider that there is also unknown here. So this unknown, since they told you that this side and this, I think this side and this side are equal, it means this is an isosceles. So here, there was also x. So for this equation here to be true, it would have been better if he had added on this other x here, plus x, plus here x, plus x, to end up with 2x is equal to 45, then divide by 2 to get 22.5. But also you have seen that also when it comes to what Virginia has done, that one is also very okay, whereby you know that here and this one are equal, and I know very well that this is 90. So you just need to know that the base angles here are always equal. So those who don't know, you can just put any unknown. You say this is R and this is R. Then you say R plus 90 will give me 108. So 2R plus 90 is equal to 180 minus 90 on both sides. And you get 2R is equal to 90. When you divide by 2, you get 45. So that's how they got 45. And then, you know, angles in a straight line add up to 180. So the angle here will be 180 minus the 45. And then you use the other property. So any approach of the two would yield the same answer. Okay. I think the rest of the numbers you'll try out in your free time to check whether you have understood that concept. Okay, so we are going to end here with this theorem, and then we go to another